So continuing in our effort to evade defenses and potentially erase tracks, we're going to take some time to talk about one of the most common methods of hiding your tracks, and that's going to be with a rootkit. Now, the overall idea of a rootkit is to maintain access as long as possible and prevent anyone from being able to see exactly what's going on that particular system. And basically, rootkits are going to be software packages that are essentially a set of tools that are used by an attacker after you've gained root level access to that system. And it's going to effectively conceal those activities on the host, permitting those attackers to maintain that access and continue to operate in a covert manner. Oftentimes, rootkits will go in and replace system files with modified files that keep track of what things you're doing and allow you to specify what to hide and what to not. Basically, these files are going to look and behave exactly like the original files so that they may not be noticed by a system or security administrator. Oftentimes, rootkits will also replace common utilities such as Task Viewer, Performance Monitor, Computer Management, the Services.MSC console. All of those things could potentially be modified and replaced to hide activities. Basically, we want to maintain normal looking functions and day-to-day operation type stuff, but we want to protect ourselves from being detected with the activities that we're performing. So the example that we give here is a rooted netstat command will list all connections except for the one you're using. The way most rootkits actually work is once they're installed on the system and the system is fully owned, then we're going to go through, and usually it's depending on the naming convention that you use. For example, you might name a file that you plan on using to scrape the SAM file, filename.exe or *_filename.exe. And the rootkit monitors for files on the file system with a prefix of *__. And when it detects that you've created that file, it immediately hides it from view so that no one else can see it except for you. Another example of this is to do the same thing with processes, to hide them and their associated identification numbers, to hide TCP connections. A lot of rootkits will actually have an alternate TCP stack altogether that maintains itself on a different IP address. So the attacker can connect into that IP address and actually never enter the logical network face of your individual machine. Now, generally, we only want to modify files that are necessary to prevent us from being detected. And the reason for this is that the more things that we change, the easier it's going to be for us to get caught. A lot of times, because rootkits are written on the fly or poorly debugged or tested, they cause a lot of problems on the systems that they're installed on. In other words, you want to affect as little as possible because that reduces the effect of you crashing the system due to poor coding or an exception error or something along those lines. Rootkits are generally extremely difficult to find. As a matter of fact, there really are only a small handful of utilities that are effective at detecting them in a Windows box. And there are just a few more for detecting rootkits on Linux machines. And I should note here, there are significantly more rootkits for Linux systems than there are for Windows systems. And personally, I think this has a lot to do with the open source versus closed source methodology adopted by Linux versus Microsoft. Because Microsoft doesn't release their source code, it's a lot harder to write replacement NTOS kernels than it is to write a replacement for the kernel of a Linux box, which is released under public knowledge. Usually we can manually detect these individual rootkits by running MD5 or SHA-SUM against the files we think might have been compromised. Now, this is only going to be good if we have an MD5 to compare it to, like a clean NTOS kernel, for example. Now, there are programs out there that will monitor for hash level changes to file system components that are critical or operating system files. One of the most common, which is both open source and commercial, is Tripwire. Tripwire is free for Linux operating systems, but is a pay by subscription basis for Windows operating systems. Once a rootkit's on the system, it's practically impossible to get rid of. It uses a technology most of the time called hooks that actually embed itself into the various components of the operating system, and effectively, the operating system is going to be a toaster when it's all said and done. So we want to rebuild that machine once a rootkit's been detected after we've properly investigated it.